Hi friends, welcome to Unit 4 Day 2 Notes. Talking now about graphing. So graphing exponential functions. This one is where we have exponential growth. So this is going to be one with growth. I know that because the value here, 2, the base 2, is greater than 1. So here I want to graph, label domain, range when the function is increasing, decreasing, constant, and then also the asymptote. If I think about this, the base, this is kind of a parent function with a base of 2. So I'm saying that exponential parent function with a base of 2. It's important to have that notation. So here, if I think about what's happening, well, a simple t-chart with some x and y values gives us a really good understanding of what's happening. And I'm going to use -1, 0, and 1. We're going to keep that consistent for part of this. -1, if I take 2 to the negative first power, well, that just turns this into the reciprocal, so I get 1/2. Anything to a power of 0 is 1, and then this will just be whatever my base is. So this graph here becomes something that looks like this. Now, as I continue to move along, this actually grows rather quickly, and I'm now off the graph. And this gets closer to the x-axis, but doesn't touch. So as I move from left to right, this is going to be increasing. This function actually will never decrease or never remain constant. As I move from left to right, it keeps increasing. My domain for this, I can have any value that I want for my x's. So my domain on this is going to be all real numbers. My range is what's affected. Now, because I didn't have a vertical shift, my range for this is going to be 0 non-inclusive. I will never get to 0. I will get really close to 0. I will almost touch it, but I will never get to 0 to infinity. Now, and we said this is always increasing. This graph is always increasing. Now the asymptote for this, it's going to get really close to what we said the x-axis, but it'll never touch that. So that's the line y equals 0 for that asymptote. So this is an instance where we have exponential growth. It's very similar when we have exponential decay. In fact, let's look at example 3 here. This is an example of decay. And why is it decay? Well, because my base value is between 0 and 1. So here, again, if I plug in -1, 0, and 1, what's happening? Well, now I take the reciprocal. Remember, anything to the -1 power, I take the reciprocal of it. Any number. So I take the reciprocal, I get 2. Anything to the 0 power is 1. And then this is just the base. So this is actually really similar to the graph that we just did, except it's reflected because it has the same base here. The bases are reciprocals of one another. So 1/2 and 2, they're reciprocals. Because it has that, these graphs are actually reflections of one another across the y-axis. It just happened to be that way because the bases themselves were reciprocals of one another. That's why we say this is a parent function with a base of 1/2. This is the example of decay, but notice that these two graphs, these are reflections of one another. The domain is the same. The range is also the same, 0 non-inclusive to infinity. But this is always decreasing. Instead of always increasing, this is now always decreasing. We decrease as we go from left to right. And the asymptote is still the same. So the characteristics of all of these functions, they have the following. They're always 1 to 1. The domain is always whatever, domain is always all real numbers. The range is always going to be 0 to infinity. But the 0 really depends upon what number you're adding or subtracting here. So if you're adding 5, then it's going to be, 5 to infinity, or it's going, it always depends upon like what's happening at that particular point. So I'm hesitant about putting 0, but without something here. So really, we'll say that this is f a to the x plus some c. So, whatever that c value is to infinity. So you'll always have your asymptote wherever that c value is. It was always 0 for these other ones. Points in the graph. So you're always going to have, notice that we always put in -1, 0, and 1. When we plugged in -1, we got the reciprocal of a, 1 over a. When we plugged in 0, we always got that 0.1. When we plugged in 1, we always got whatever a was. So just keep that in mind. All right. Join me in the next video as we talk about then graphing transformations given these particular values. Have a good day.